Well, hello everybody. Welcome inside Mission Control. We're welcoming the East Paulding Middle School students in Dallas, Georgia. We know you guys are outside Atlanta, and I'm very pleased to have Heather Paul with me. She is a mechanical engineer. She graduated from high school in Atlanta, so she's very familiar with that area. She currently is a Crew and Thermal Systems Division engineer here at the Johnson Space Center, and you're inside Mission Control, where the flight control team oversees all the operations of the International Space Station. We are very pleased to have you guys with us today, me and Heather, and she's going to handle all the hard questions that you guys may have for us. And Michael and I guess April Leachman, you're the teacher for these students, so we're ready for y'all's questions.
Hello, my name is Clark Poss, and my question is, if we ever live on the moon, how will we transfer oxygen?
Clark, that is a very, very important question to think about because the moon doesn't have an atmosphere, so we would have to provide our own oxygen for the astronauts to live. And we may bring some of the oxygen with us, but most likely if we're looking at living on the moon for a longer period of time than we did in the Apollo days, we're going to have to figure out a way to generate that oxygen. So that is something that our engineers are working on right now, in fact, and not only generating the oxygen, but recycling the oxygen that we use. You know, we breathe in oxygen, we breathe out carbon dioxide, so how could you recycle the oxygen out of your exhale and make sure that you pull the oxygen molecules in and maybe even generate oxygen from the carbon dioxide molecules? Great question.
Great question.
Hello, my name is Seth Grennan, and will we ever be able to walk on the moon or walk on Mars?
Seth, you know, that's a question I often ask, and we are working on our spacesuits and our vehicles and our robots and rovers to get us there and to work on the surface of Mars. As far as when that will happen, you know, it's a challenge to get there. It's a lot further away than the moon. The moon only took us about 2 to 3 days to get there to get to do our work. Mars is a lot further away, so it could take us anywhere from 3 to 6 months to get there. So you got to let our engineers work hard on that new vehicle we're developing and our new suits and rovers and robots. And then hopefully maybe your classmates will get to either work with us here to be in Mission Control Center or even fly and be a part of that crew.
Thank you.
Hello, my name is Riley Rawson, and my question is, aren't you ever worried that from the rockets, the fuel, that it will pollute outer space?
I see. That's a very environmental question. Absolutely. And we do a lot to really make sure that we understand where everything that we put out of our vehicles goes, whether it's our rocket fuel or even our trash or other things like that. So we're very, very aware of what kinds of things we're putting out into the atmosphere or, in the case of space, the lack of atmosphere.
Thank you. My name is Brennan Kuda, and my question is, can you tell the weather from space of what the weather would be like on Earth?
Absolutely, and in fact, if you watch the news and you learn about, storm systems, whether it's rain or snow, all of those that information is coming from our satellites that we have positioned around our planet, in part thanks to our space shuttle and space missions. And so, a lot of what we're doing in our space program is not only to go explore places like the moon or Mars or even an asteroid, but a huge influence is to make sure that we are affecting and benefiting life here on Earth, and that's through monitoring the weather and keeping everyone informed.
Thank you.
Great question.
Hello, my name is Devin Spain, and I want to know how you assure that the astronauts have enough oxygen to survive in space.
Yeah, great question.
Excellent. I'm loving these life support questions because that's a lot of what I've focused my engineering career on, is making sure the astronauts have not only enough oxygen, but good, clean, breathing oxygen to keep our astronauts alive so they can do all of their work in science on board the space station. So we bring up oxygen with us when we fly, but then we also can generate oxygen, and we recycle that oxygen as well. Our spacesuits have oxygen tanks, so it's kind of like your own portable breathing apparatus inside of the life support system, and then we have adequate oxygen on board the space station as well.
Thank you.
My name is Patrick Huntington, and is NASA competitive with any other space programs? If so, who are they?
Good question. Well, back in the day, Patrick, we were actually in a space race with what are now our partners, the Russians. So a long time ago, we were under more of a competition, but nowadays, it's really all about teamwork. We have 16 international partners in working on the International Space Station, and it's more important to think about how we can work together instead of competing against each other. And we not only have our international partners for Space Station, but we've now branched out to our industry partners. We just launched the Cygnus, so that is a great example of one of our new commercial spacecraft that is going to connect with our space station in just a few days.
Thank you. My name is Neil Jackson, and I want to know what rocket fuel is made of.
What rocket fuel is made of?
Neil, what rocket fuel is made of? Well, that depends on the rocket, I suppose. Our space shuttle had solid propellant as well as liquid, and I don't know the exact formulation because that is not my area of expertise. But really, when you think about where you're going in space, that's going to determine what kind of propellant you would use. So if you're going into low Earth orbit, you probably don't need as much as you would need if you were going to a place like the Moon or even further like Mars. It's a very good question.
Thank you. Hello, my name is Connor Pitts, and my question is, what is your plan to put people back on space?
Well, Connor, we have people in space right now on board the International Space Station, living up there for about 6 months at a time, and we just recently selected our first astronaut and cosmonaut who are going to live on board the space station for 1 year continuously. So we have people up there pretty much 24 hours a day, 7 days a week right now. Now, as far as looking to our next destinations, we're trying to figure out if we want to go back to the Moon, which would be pretty cool in my opinion, or maybe even go and find an asteroid and bring it back closer to Earth so we could study it, or eventually go on to Mars.
Thank you.
My name is Olivia Rozika, and my question is, what materials are in the present-day spacesuit?
Excellent question. And there's several different layers in our spacesuit, and all of those layers are important because they make sure that the astronaut stays alive inside of the suit as well as thermally protected. So we first have a layer that kind of acts not as flexible as a balloon, but a balloon, when you inflate it with air, it holds that air in, especially if you tie it up really tight. Well, because we essentially inflate our spacesuit with oxygen, you need a layer, a pressure layer, that's going to hold that oxygen in. But once you inflate a balloon, it tends to get kind of rigid, and it wants to stay in the shape that it's been designed to be. The spacesuit is no different. So then the second layer is what we call a restraint layer, and it's made out of Dacron, which is found in a lot of camping equipment. It's a very nice, lightweight, somewhat flexible material, and we can sew that material to make the spacesuit into more of a human shape, and that's what's going to hold that bladder, that pressure layer, in and make sure it doesn't overpressurize. And then we have a multi-layer garment that first starts off with neoprene, and if any of you are interested in scuba diving, you would wear a wetsuit that's primarily made out of neoprene to make sure that you stay nice and warm, especially as you go deeper into the water environment. Well, we have neoprene in the spacesuit for the same reason, to keep our astronauts comfortable inside. Then we have multiple layers of a really shiny material called mylar, and if you've ever gotten a happy birthday balloon from a grocery store, one of those shiny ones, that's typically made of a thicker mylar than what we have in the spacesuit. Or here in Texas, every day in summer, we have to put up those sun shields in the car, otherwise the car gets really hot. Well, mine is made out of mylar, so I always think about that. Hey, cool, I'm in a spacesuit right now. And then the outer garment that's white is actually a combination of materials, Nomex, which is in a lot of our firefighter suits, Kevlar, which is in bulletproof vests, and then a little bit of Teflon as well. So a lot of really common materials that we use here on Earth, we've developed into a garment that makes the spacesuit.
Thank you.
Great question.
Hi, my name is Hannah Vandermeer, and my question is, what's the farthest planet that NASA's been to?
Excellent question. Well, the farthest that we've been with humans is to the Moon, and that's not really a planet. But of course, we've got our rovers on Mars right now, and we've got a lot of different vehicles that are out there exploring space even beyond. And I think one recently just even went beyond our solar system.
Yeah, Voyager 1.
That's right. Voyager 1 is out there collecting great information for our scientists and engineers.
Thank you.
Hi, my name is Drew Patterson. I was going to ask, how many degrees have you earned?
All right, Drew. Well, that is a great question. I started off.
It's going to be a long answer.
I started off at Auburn University in Alabama, and I studied mechanical engineering and Spanish, so I have 2 undergraduate degrees. And during that time, I actually was also a student working at NASA, so it was a great way to kind of get some work experience in to try to figure out what type of engineering work I'd want to do when I eventually got hired here. I then went to the University of Texas at Austin to continue my mechanical engineering studies, and I got a master's degree there. Then I joined the NASA workforce, and a few years afterwards, I realized that I just was not done with my education, and I went to the University of Houston Clear Lake and got a master's degree in fitness and human performance to really get a better understanding of how the human body works when we're under exercise. And I've spent a long time working with our spacesuit team, and we talk about working in the spacesuit is really about 6 to 8 hours of exercise. So thinking about how to prepare enough oxygen for them to breathe, you have to understand how that exercise affects your heart rate, your lung capacity.
I think that's a really good example of how your education can continue even after you finish school. I know you're probably thinking right now, oh, I don't want to go to school anymore, but you may want to once you've gotten out and you started working and you say, there's so much more that I want to learn. And Heather's a perfect example of someone who continues to want to learn even after being a professional and working after school. And so that's a really good question. And you guys don't feel like you stop at high school or college. You can keep learning even after you're working.
Hello, my name is Leon Ondieki. My question is, how many gallons of fuel does it take to launch the rockets to the moon?
Man, this is a toughie. I don't know. I'd have to go and look that up.
Yeah, I know that the space shuttle, which we just retired, obviously, it's about 500,000 gallons of propellant, oxygen and hydrogen that's required to get a space shuttle into orbit. And the moon rockets back in the late 60s and early 70s was even more than that. Remembering that the atmosphere is very thick, and the hardest part of a rocket launch is actually the first 2 minutes or so. Once you get past that, you get into the thin part of the atmosphere, the vehicle's engines start accelerating the vehicle because the atmosphere is so thin, and suddenly you get to a point where you're almost out of the atmosphere completely. And so you don't need as much propellant to move around once you're in space, but you still require it to move. But that's a great question. It takes a great deal of propellant to break Earth's gravity, and so living in space and moving from space to further, deeper space, may eventually be the way to go, and produce propellant depots in space where you refuel like a gas station and then go further because you might not need as much out there. That's a great question.
Really great, and that really relies a lot on orbital mechanics too, understanding how if you can do a loop or two around a planet like Earth or maybe even around the moon, you can use that gravitational pull to essentially slingshot your vehicle, so maybe you don't need as much propellant. The more propellant you have on launch, the heavier your vehicle is, the harder it is to really get up into space. So our engineers and our scientists are really smart about looking at all the different options for if we want to go from Earth to a destination, what's going to be the most fuel-efficient way to get there.
Thanks.
Hi, my name is Kennedy, and I was wondering, how long did you stay in college to have this job?
Good question, Kennedy. Well, I was at Auburn University for a total of about 4.5 years. That's my time that I was actually at school. but I was also taking some time to do a semester at school and then a semester at NASA. So it took me probably about 7 years total to get through my school as well as my work experience. And I decided to extend out my work experience a little bit because I just loved so much working here, and it really helped me to understand what all of those theories and those homework projects that I had to learn at school, how to apply them to really cool stuff that could fly in space. So I thought it was an important thing for me to really do my research here at NASA too, to figure out where I would best fit in and what I wanted to do with my career. Then my graduate degree took me about 2 years, and even then I was still alternating between a semester at school and a semester here in Houston, Texas.
Hi, my name is Danny. What is your favorite part of your job?
Oh, Danny, wow. I wish I could answer several things. I think one of the favorite things that I think about when I get to work here is working with this great team of people. It's really all about teamwork here. When you look at the Mission Control Center, there's several people here that are all working together as a team to make sure our astronauts are living successfully and working on board the space station. And even behind the scenes, we have rooms full of people that are supporting each person here in Mission Control, and then engineers and scientists all across Johnson Space Center, all across the United States at our different NASA centers. And just the amount of teamwork and effort and communication, it's just amazing to be a part of. And then the other thing I like to think about with my engineering career is I really see myself as a problem solver. So if you like solving puzzles, whether it's Sudoku, a crossword, or putting a jigsaw puzzle together, that's really the heart and the essence of engineering, is being willing to look at a problem and see it as a creative challenge, and how can you overcome that and fix that problem. So I like to say we're problem solvers.
Hi, my name's Abby, and I was wondering about how old you were when you decided that you wanted to become an engineer.
That's a great question.
That's a great question, Abby. I was interested in space from a very, very young age, but when I decided I wanted to become an engineer was probably about your age. I started realizing that to be an astronaut, you could go down a couple of different career paths, and one of them was engineering. And the benefit with going into engineering was that if I didn't end up getting selected to be an astronaut, I could do what's really a very close second, which is be an engineer that works and trains the astronauts and develops the hardware that the astronauts get to use in space. And in fact, a lot of the training that our astronauts go through, our engineers have to do as well, especially when you're thinking about a spacesuit design or some hardware that the astronauts are going to use. Our engineers have to be familiar with working with that same equipment so that if there is something that happens in space, we can replicate it or simulate it here on Earth. So really, being an engineer for NASA is something that I thought about a long time ago. I didn't know which kind of engineer I wanted to be, but once I started looking at colleges, I realized that mechanical engineering was the way to go because of all of the different opportunities, the really foundational aspects of mechanical engineering would allow me to do just about any other type of engineering.
Thank you.
Hi, my name is Bonnie, and I was wondering what qualifications do you need to be an engineer in NASA?
Excellent question. Well, you first of all have to go to college and study some kind of a technical degree, typically engineering, and get your Bachelor of Science degree in engineering. And that can be mechanical, chemical, electrical, computer, industrial. I work with so many different types of engineers, and really realizing that you may not even need to do that kind of engineering ultimately, because really we have to be able to kind of merge into other aspects of engineering. So a minimum, I would say, is a Bachelor of Science degree. Now, some of our engineers like me choose to go on and get a master's, but it's not required. We also like to make sure that you have some work experience. So if you're interested in engineering, start looking at opportunities for internships, whether it's here at NASA, which of course I highly recommend, or with one of our contract partners or one of our commercial partners. There's a lot of opportunities out there to get that work experience.
Thank you. Hello, my name is Angelica Santiago. My question is, how does a person sleep in space?
A very important aspect of living in space. You got to make sure that you get enough rest. We have crew quarters where the astronauts basically can kind of close themselves up in their own little personal space. And really what they sleep in is something that looks a lot like a sleeping bag. They climb into it, their legs go in, and one of the more interesting things that the astronauts have shared with me about sleeping in space is that they miss that sensation of resting their head on a pillow. So we had to design a head strap that would go across the astronaut's head to tilt their head back and then rest on the back of their sleeping bag, essentially, to give them that feeling of sleeping. And a lot of times our astronauts can choose or not choose to restrain their arms. So sometimes if you see astronauts sleeping in space, their arms have risen up and they look a little bit like a mummy just in time for Halloween. But I've heard it's very comfortable to sleep in space. And really we work our astronauts pretty hard and they do a lot of great work for us. So by the time they get to lay down or float and sleep, they're ready to catch a few Z's.
Hi, my name is Sophia Margwin, and I'm wondering, why did you decide to be part of NASA?
Excellent question. Well, back when I was about your age and I started looking at the different career options that were out there, I was so interested. I was already tied into what NASA was doing through various things with school, and I really just decided that to be an astronaut or even an engineer working in the space program, NASA was the place to be. Nowadays, there's even more opportunities. Of course, NASA is really at the forefront of working with our International Space Station and looking at future technologies, but there are a lot of contractor partners that we work with that offer a similar experience, and we have all of our international partners, so really the opportunities are even greater for you guys that are interested in working for the space program.
Hi, my name's Emily Rogers, and I was wondering if you were working on any new spacesuits.
Hey, Emily. Well, I love that T-shirt, so War Eagle to you. Absolutely. We are working on new suits right now, and we're trying to make our suits kind of multi-purpose because we don't know yet where we're going, but we're really focusing a lot on a suit to work with our new Orion vehicle, and it's going to look kind of like the suit that we wore when our astronauts launched and landed in the space shuttle, the bright orange Advanced Crew Escape suit. We're working on modifications to that to work with the requirements for our Orion program. And then we've got our engineers off working on a surface suit as well, something that's going to be a definite upgrade from what we used on the moon, much more mobile, hopefully lighter weight, and hopefully more efficient with the life support system. So maybe we can stay out longer or wear less weight on our back. So stay tuned, and maybe hopefully you can join our team as well.
Thank you.
Hi, I'm Elijah Pate, and I was wondering what happened if an astronaut gets sick. Can they go home early?
A very important thing to think about. Now, our astronauts are trained in a little bit of medicine so they can kind of help each other, and we have some certain medications up there if they get a little under the weather. If it became really serious, we'd have to evaluate how to get them back home. But really, our astronauts are very, very well trained to take care of themselves in space. We also have a flight doctor that is here in mission control that monitors the crew health and makes sure that they're feeling well enough to stay up there and do the job.
And if it's really an emergency, they do have their spacecraft that's always at the space station, so they can come home in an emergency fairly quickly.
Mm-hmm. Great question.
Thank you.
Hi, my name is Madison Essen, and I was wondering, what have you learned from the Voyager 1 now that it's out of our solar system?
That's an excellent question. You know, I think we're excited to see what we learn from Voyager 1. I think it just left not too long ago. So we have a little bit of time to figure out what we're going to see next. So hopefully stay tuned to the NASA.gov website, and we'll keep you guys informed. And the other great program that we're working on right now is the James Webb Space Telescope that is going to be a huge improvement. We've got the fantastic Hubble Space Telescope up right now, but James Webb is going to let us see even further out there to see what's going on. So there's a lot of really exciting things going on in the space program right now. I'm so excited you guys prepared these amazing questions, and I really do hope that you stay tuned in, and I hope that you can come and join our team.
Yeah, we really do appreciate you guys coming into Mission Control and joining Heather and myself. We've had a great time, and as she said, those were great questions. And as she also alluded to, you kind can see, there are a ton of different jobs out there in the aerospace business and NASA and all the contractors. So we certainly would love to have you guys come and join us when you guys get out of college, and we're looking forward to it. And thanks again for coming and joining us here in Mission Control.
Thank you.